Hey everyone, and welcome back to this class, Advanced Convolutional Neural Networks. In this lecture, we are going to look at the code for how to implement a CNN in Keras and use it on the Fashion-MNIST data. What you're going to see is really how easy this is in Keras. Pretty much just a matter of reading the Keras documentation for a few minutes. So our strategy is as usual. Load in the data, create a neural network, which you'll see is basically just a matter of declaring a list of the layers you want, train the network, which is just one line, and then plot the cost and other metrics. But of course, this is easy because this is review. If you're having trouble understanding anything you see here, then you'll probably want to take a second look at what you were supposed to know before starting this course, since that will better prepare you for the rest. So we are looking at the file fashion.py in the course repo. At the top we have some Keras imports, just the model type we want, which is sequential, and then all the types of layers we'll need. We've studied all these layers in the past, so you have a very good idea of what they're doing and why we are using them. At the top we have a function called Y2Indicator. This is because Keras targets can't be a list of indexes, they have to be one-hot encoded. Keras also has a function for this called toCategorical, but I decided just to keep my own since I already had it. Next, as promised, we load in the data. This is the same format as MNIST on Kaggle, so you could essentially copy any code from a previous course that loaded in the same data. Keras is going to do a train split validation for us, but I'm also shuffling the data here just in case. Remember that we want the data to be in the shape of n by height by width by color, so we reshape it to -1 28 28 1, since the images are 28 by 28 and they are grayscale. We also like our image pixels to be normalized, so we divide everything by 255. And just like the original MNIST dataset, the labels are in the first column, so X is everything from column 1 and onward, and Y is everything in column 0. Next we get K, which is the number of classes, and on the next line we turn Y into an indicator matrix so that we can use it in Keras. In the next section of the code, we create the model. We start by initializing a sequential object, and then we call the add function for every layer we want to add. So here I'm using a pattern you're going to see a lot in this course. Conv batch norm maxpool. We do that twice, and each time the image gets shrunken down, but the number of feature maps increases. So here it's 32 and then 64. Next, we flatten the data so that we can do a couple dense layers. So we have a dense activation dropout, and then a final dense with softmax. Pretty standard CNN. Next, we compile our model. We're going to tell it we want to use the categorical cross entropy, since we're doing classification, and we want to use the atom optimizer, and we want the accuracy to be returned in the history. Next we call the fit function. Nice that it's just one line, but this actually does a lot of stuff. First, it automatically splits up the data, so we don't need to do that. It applies the optimizer and prints out the progress and saves it, so we also don't need to do that. This is usually a big chunk of code for us. Lastly, we plot the loss and accuracy. Notice how we get both the train loss and validation loss, as well as the train accuracy and validation accuracy, all for free. So let's run this and see what we get. So we get about 90% validation, which is pretty great, considering this basically took no effort. And so we just built a standard CNN with the usual architecture, with just a few lines of code, and we're already doing pretty well. And by the way, just as an aside, you can also check out fashion2.py, which is the exact same as fashion.py, but it uses the Keras functional API. So if we scroll down to the relevant part, that's where we make the model. So with the functional API, you build up your model by creating layers as usual, but instead of adding them one by one to the sequential model, you instead pass a data graph node through each layer. So this is called functional because each layer is actually callable, meaning you can put parentheses after it and call it like a function. It takes as input a data graph node and returns an output graph node. When you're done passing it through all the layers, you create a model instance, and then you just tell it what are the inputs and what are the outputs of your model. Note that it's pretty usual just to name everything X in Keras. And we'll be using the functional API pretty often throughout this course, so make sure you're comfortable with this syntax.